Hello students, welcome back to my YouTube channel and I have started with a new series in which I am talking about the solutions of the system equations and this is my next lecture in which I am talking about the direct methods. So, direct methods, how we can find out the solution. In the previous lectures, I have discussed about the consistency, the inconsistency of the system of linear equations. Now, there are different methods to find out the solution. We have done one method that is using the rank, right? So that's the very general way of finding the solution. So in today's topic, we'll be talking about the direct methods and we have various methods inside this. So let me just introduce you with the various direct methods that we have. So let me just tell you about some of the various methods. The first one that I'll be talking about uh, is the Gauss elimination method. So Gauss elimination. Then we have Gauss-Jordan method. Then we have Cramer's rule. Matrix inversion method. And lastly, we have the LU decomposition method, which is again categorized. So I'll just write LU decomposition method. So it is further subcategorized into three types. So let me just write them. They are Routes, Doolittle, and Cholesky. So we have three different methods under LU decomposition method. So these are the direct methods and in the further lectures, we'll be discussing about the direct methods only. So I'll be starting with the first one that is the Gauss elimination today. So let me just write the topic here that is Gauss elimination. So yes, so in the Gauss elimination, everything I have already discussed also in the previous lecture when we were talking about the echelon form. So it is somewhat similar to that only. So what we do in this Gauss elimination method, we consider two steps. So two steps that you have to keep in mind. The first step while performing the Gauss elimination method is the forward elimination. Forward elimination. In this step, what we need to do, we need to apply the elementary row operations on the augmented matrix C, and you have to transform the matrix to a upper triangular matrix. Okay, so in the forward elimination method, in this, we transform C, that is the augmented matrix, into an upper triangular matrix using elementary row operations. And the second step that we have is to find out the solution. So I have explained it earlier, that is backward substitution. So backward substitution is you have to calculate the values. So in this, the values of xi's are calculated by back substitution as we have done earlier. So this is going to be a very simple method for you because I have already explained this while we were calculating the rank of the equations. So let me take one example. So I'll take a question here. You need to solve using the Gauss elimination method. So solve the system of equations using Gauss elimination method. So let us consider the equations. So this is what we need to solve. So solution means you need to find out the value of x, y, and z. So let us consider how we will be starting. I can here I can write this as ax is equal to b. So my A is the coefficient matrix as we have discussed earlier in the previous lectures. X would be the column vector with the unknowns. B is again the column vector with the BIs, the constant values. So as you could notice here, this is a 3 cross 3, 3 unknowns, 3 equations that I have. Now, what is my augmented matrix? So consider the augmented matrix. Any notation you can use, right? And this is my augmented matrix. So let me write this. Yes. Okay. Now, now we'll be doing the first step. Now the first step is given as you have to transform your augmented matrix into an upper triangular matrix using the elementary row operations. Now what is the upper triangular matrix? I have already explained. The upper triangular matrix is where the below the diagonal elements um, are 0. So upper triangular matrix is basically upper triangular matrix is generally like this, right? So I have explained this to you in the previous lecture as well. So you have to transform it into this form. Now, here one more thing that you have to keep in mind is the pivot element. So the pivot element that you will be taking would be the first A11. Okay. So let me just take A11 as the pivot element or just pivot, and we need to reduce the other elements, all the elements in the first column below A11 to 0. So we have to put, we have to convert the A21 and A31 to 0. So we'll be applying the elementary row operation. So let me take the elementary row operations as R2 goes to R2 minus 3 upon 2 R1 1 upon 2 R1. Okay, I have already explained that in the elementary row operations, how do you identify this multiplier? It's very easy to remember. So you just need to understand which row you want to make 0. So that's come on the left hand side. no multiplier comes for those rows where you need to make the changes. That means where you want to make the zero element. Okay. Now, write which element you want to make zero. This is A21. So A21 come up upon the pivot element A11 multiplied by the row 1 in which the pivot element lies. Similarly, R3 goes to R3. I want to make A310 upon A11 R1. This is how I can formulate my elementary row operations. So this is important to understand how we can formulate these elementary row operations. So this is how you can do it. Now, when I move ahead, when I'll make these zeros, so what would be my C matrix? So this is an equivalent sign. So this first row would remain as it is. So 2, 1, 1. Okay. So now as you could see here, this is 3. Okay, so 3 minus 3 upon 2 into 2, that is coming out to be 0. Let's talk about these. So 2 minus 3 upon 2, 1. So this is 4 minus 3 upon 2, that's half, right? Similarly, for this element, this would be 3 minus 3 upon 2. That's 6 minus 3 upon 2, 3 by 2. So I have got the elements of the second row, 0, half, 3 by 2. And on the similar basis, I can calculate this. This is 18 minus 3 by 2 into 10. So this becomes 5. 18 minus 15, that's 3. So this is 3. Very easy to calculate all the elements using the elementary row operations. Now I'll be finding the elements of the third row. Okay. For the third row, the first element is 0 because we need to make that. Okay. Now second, 4 minus half into 1. So because this is the element corresponding to the 4. So I am getting here 8 minus 1 upon 2, 7 upon 2. Similarly, 9 minus half would be 18 minus 1 upon 2, that's 17 upon 2. 16 minus half into 10, that's 5. So 16 minus 5 is 11. So these are the elements. So I'll just substitute there quickly. 7 upon 2, 17 upon 2, and that's 11. Very easy to understand. No problem at all. Now, to make it an upper triangular matrix, these two elements are done, have become 0. Now I have to make this 0. Okay, so let me just erase this part here. Okay. Now moving ahead to the next page, I have to make this 0. Okay. Now to make this 0, what needs to be done? I will take the pivot element as A22. So always remember, whenever you are taking the pivot element, you need to encircle that so that it is very easy for you to understand. So now take A22 as the pivot element and reduce all the elements below it to 0. You have to make them 0. Now, what would be like here? I have taken the elementary row operations. So there also I'll be taking the elementary row operations as row 3 goes to row 3 minus. I have to make this 0. So this would be A32 upon A22, the pivot element. And the pivot element is lying in row 2. Okay, so now what is my, I can rewrite this as row 3 minus A32 is half. So this would be half upon 7 by 2 R2, which can also be written as R3 goes to R3 minus 1 upon 7 R2. So this would be my final. Let me just box it. And this would be your final elementary row operation. So when you will apply this, I'll get The first row, no change. Second row, no change. 10, 3. Now the changes would be done in the last row. So this is 0, this is 0, only these two elements. So what would be these two elements? 17 by 2 minus 1 upon 7. R2 is 3 upon 2. So I'm getting this as 17 upon 2 minus 3 upon 14. So when you will solve it, I'll be getting the final answer as minus 2. Similarly, I'll take this as mm, wait a second, I have made a mistake here. Just a second. So 832 was 7 upon 2 and this is half. So this would be minus 7. And this is like this. So I'll be taking this as 21 upon 2. Okay. So this would be minus 4 upon 2. That's minus 2. Okay. Now the next that I have is 11 minus 7 times 3. So that's 11 minus 21. That's coming out to be minus 10. So this is what I'll be getting the elements. So please you can check with the final this. This is important, right? So do refer to this one. Now, first step is done. I have reduced it to the upper triangular matrix, right? Now I'll be doing the back substitution. For the back substitution, how you will be writing this? Either you can write this as this can be 2, 1, 1, 0, half 3 by 2, 0, 0 minus 2, x by z, 10, 3 minus 10. So the back substitution means, please notice this, back substitution means like this. Okay. So what we'll be doing first, find z, then y, then x. That's known as the backward substitution. So what equations you would be getting here? Minus 2z is equal to minus 10. So you will first calculate the value of z. So you can also write it as 0x, 0y minus 2z is equal to minus 10. So here you will get the value of z as minus 10 upon minus 2. So z is equal to 5. Then the 0x half y 3 by 2 z, 0x plus half y plus 3 by 2 z equal to 3. Just put in the values. So that's so I'll get here after solving this, this is 6 minus 15, that is coming out to be minus 9. So I'm getting y as minus 9. And the last equation, 2x plus y plus z is equal to 10. So 2x plus y plus z is equal to 10. Substitute all the values. This becomes minus 4. That comes that side. So that's x is equal to 14 upon 2. So x is coming out to be 7. So here I get all the values, that is the solution of the system of equations. So I am getting my x, y, z as 7, minus 9 and 5 respectively. Also, you can write in the end, thus the solution is capital X, first x, then y, then z. So this is my final answer. Very easy to do the elementary row operations for a Gauss elimination method. So we you can also get questions related to 4 equations and the 4 unknowns. It is very easy to solve them. and the Gauss elimination method is used to find the system of the linear equations. So in the next lecture, I'll be talking about the Gauss elimination pivoting part. Where we have two kinds of pivoting, that is partial pivoting and the full pivoting. So in the next lecture, I'll be talking about the partial pivoting. So stay tuned and we'll meet in the next video. Thank you.